Okay, starting from next lecture, first things that I will do in the lecture is taking the attendance. And any student come after that should not ask me to take his attendance, okay? Because I see around 30, 35 students out of 115. Then, if the remaining students coming later, they will disturb us, like this one. He's knocking the door, trying to open the door, okay? And saying salam also. So those students who came late, disturbing us. I don't want to say don't come to the lecture if you come after me, but try to come before me, because from the next lecture, I will take the attendance early and I will not take it for anyone who come late, okay? So, today, quickly a little bit because not you. We in the department have meeting in the rector office at 11:30. So let's try to finish within first two parts of the lecture, the week 4 lecture note. If you remember, last week we mentioned the statistic and probabilities, and we mentioned the Bayesian doesn't matter. It's Bayesian in some cases, pronouns, decision theory. Review, okay, what we talked in week 3 about Bayesian decision theory. We said it's a fundamental statistical approach, a way for static to trade off, the way of choose between some decisions. This type of trade off using probabilities for this decision and the cost to take this decision. Yes, please. Then, okay, why you around 15 students until now, and maybe another 20 students will come late? Why? Don't say bus, don't say dolmush. The lecture is not 8 a.m. Okay? Next time, everyone should come before me, not after me. Because if 30 or 40 students come late, this means we will not give the lecture. Okay. So we know the probabilities for some things. For example, from experts, we could know the probabilities to do some job. For example, if we fishing in the winter in some place, okay, and we bring some experts, fisherman, he will said probably maybe 70% of the fish in this place in the winter will be salmon will be sea bass will be something else. Okay, so you know the probabilities, but if you use the probabilities alone, you could have problem. And we mentioned the example for the manufacturer who make buckets for the salmon and sea bass. And we said there's costs here if you make wrong decision using only the probabilities. So this Bayesian decision theory also take into consideration the cost. We will take an example about this. So because it's taking the cost, it's minimizing the risk. Why minimizing the risk? When you choose the decision depend on the probability, okay, you have some risk. But when you take some other consideration like the cost, you will decrease or minimize the risk in this case, because when you take the cost into consideration, maybe if the cost of selecting salmon will be very high and you have, for example, 50-50 or 60-40% for probability, and the cost of choosing salmon as the classification will be very high, then in that case, you will choose, for example, sea bass in our previous example. Why? Because the cost of mistakenly choosing the salmon, not sea bass, will be very high, for example. And so on. We will take it. We took this one. We said that, for example, we have two classes, W1 and W2. W1, which we said in our example, you remember our example about fish sorting, yes, or classification of the fish. We said W1 is sea bass and W2 is salmon. Okay. We name the probability of W1. We write it as capital letter. Focus here. There is another probability. We will write it as small p letter. Prior probability. Why it's named prior? Means from our experience, we know that, for example, the probability of having sea bass will be, for example, 60%. We could write it like this, or we could write it like this. And the probability of W2, for example, if we have only these two types, will be 40%. Because if we have only two classes, then if we have only these two classes, probability of W1 plus probability of W2 should equal how much? 1. Yes? Because we have only these two classes. We name this prior probability because we know it before, this probability. But okay, we know the probability. So, okay, this fish, okay, it's according to this percent. Without looking to the fish, we select a fish, we will classify it to sea bass, yes? What if it's salmon? We should know the cost of wrongly select the sea bass instead of salmon, wrongly select the salmon instead of sea bass. So, as I mentioned, the prior probability, it's about our knowledge of how likely or likelihood of some action to happen or some class to be selected. Okay, that's why we name it prior probability. We mentioned all this. I mentioned that if we have only two classes, then the summation of probability must be 1, because any probability must be less than 1. If the probability 0.5 for everyone, so it's equal probability. If the probability 1, for example, for W1, it's 1. So this means we are 100% sure it's W1. This means it's not W2. Yes? Then we mentioned this. All this just review for what we mentioned last time. Then when I take decision, I will select W1 if the probability of W1 it's greater than the probability of W2. Okay, so taking decision of W1, how much will cost you? W2, the probability of W2. Yes? So when we take the minimum, this means probability of error. When we take the maximum, probability, this means the probability of error, it's the minimum between W1 and W2. Why? In Arabic. Why? Because when we select the maximum probability, so the error it's the minimum 1. So if a probability of W1 is 0.6 and W2 it's 0.4, then we will select W1 because its probability is 0.6. So what's the probability of error in this case? 0.4, which is same like probability of W2. And we said last time also, we use the class conditional probabilities. So we start to use the other probability or condition or other features of this class to be sure more about selecting the class. So we said like this. As you can see, we write it as P small, P small. It's a class conditional probability K for W taking into consideration X. So X taking into consideration the class. So if we have two classes, this means we will have, for example, Px when we have W1 and Px when we have W2. If we have three classes, then we have P. What X? X, the feature that we will take it into consideration when we take the decision. That's why we name it conditional probabilities. So we start to take some other conditions to minimize the risk, to minimize the cost. Okay. Instead of not looking to the fish and select the fish and said, okay, it's sea bass because 0.6 or 60% of the fish will be sea bass. Now we can look and not we, of course, the camera and the device, look, for example, for the brightness. If it's in specific level, then it will increase probability of, for example, sea bass, or increase the probability of salmon, depend on this feature. Okay, and we mentioned it here. So if we take X as the lightness, so if the lightness, for example, 11 here, or not 11, 11.5, okay, so we almost said this class is W2. It's increased the probabilities. Of course, if you take the probability of W2 and W1 here, it should be 1 if there is no other classes. Here, we consider some real data, so it have more classes, okay? But we focus on class W1 and class W2. We will take all this using examples and calculation. So the Bayes theorem or theory, it's using the conditional probability. Conditional probability, this one, it's known data. We said if the probability, this one, for example, if the lightness 10, then this A could be 1, this probability, for example, 60%. So this comes from where? It's conditional but prior probability. We know it from the knowledge, from the experience, yes? And probability of A means the class here. B means the feature. Okay? So probability of the class, a specific class, we know it. From where? Also from the experience. But we don't know probability of the feature, so we need to calculate this one to get the probability of class 1. So we will classify it class 1 or class 2, depend on specific feature. To classify A to A1, A2, any class, okay, depend on the features, we will use this rule, which is, or theorem, which is, where is it? Okay, which is Bayes theorem, which said the conditional probability of B giving A, I told you, it's given to you, or known from the experience, probability of the class, we still need to calculate this one. To calculate this one, we have this rule. Okay, so not this one. This is another way to write it. To write same with this one. It's like this. Okay, so probability of B, it's the summation of n. What n? Number of classes. For example, if we have one class, so probability of n equal 1 to 2. If we have 3 classes, 2, 3. If we have 4 classes, 2, 4. Probability of P, N, P, A. What's this one? Probability of the classes. We know it. We said it's given to you. Probability or conditional probability also given to you. Probability of P giving class A 1, probability of B giving class A 2, all this data given to you. So it's the same. This one, it's same, but we said how to calculate this one. probability of the feature. To calculate it, we can use this rule. I need from you to differentiate. What I mean by differentiate. You have to know this rule. This is the general rule. We will use it. Okay? And you have to know this separately. This one. What's this one? Probability of B, it's equal summation of n number of classes. Okay? Number of classes. So summation of number of classes, probability of P given an. So n, first time will be 1, second time will be 2, third time will be 3, and so on. And probability of the feature, of the class, sorry. So A here in this one, A, sorry, A, N, it's the classes. Okay, class A1, class A2. E, it's the feature. Okay. When we said probability of PA or BA, this classes. Take examples to calculate this. Okay, we will give examples later. Okay, so for our example, let's return. We need to, by the way, this one, okay, this one, we name it posterior probability. It's a probability that we need to calculate it. Probability of a specific class giving specific feature. Okay, so it's from the Bayesian theory. Probability of the class given the feature. Okay, so we need to calculate what's the probability of getting class W1 if we have, what's the probability of getting class B2, W2 if we have X as 10. Then depend on these probabilities, we will know what's the class. It will be W1 or W2. So shortly, this is the general rule to calculate what the probability of a specific class given specific feature. So X is the feature, yes. This is a Bayes formula for posterior. Posterior means the probability that we need to calculate for specific class given specific feature. Okay. Okay. We can give at 10:20, we can give short break only because we will leave early. So I will not give a long break because we have meeting. I have meeting on 11:30, so we will leave almost 11:15, something like this. Okay, so we mentioned this one now, but we mentioned it before. You remember? Last time we said the decision without looking to conditional probabilities. Yes, it was like this. Decision probability of W1 greater than probability of W2. This high cost or high risk have high risk. Why? Because we did not get any condition using some features. This one, of course, later we will see how to take set of features, not only one feature for classification. So the decision will be W1 if the, what we name this one, the posterior conditional probability of W1 given X greater than W2 given X. So if the posterior probability of W1 given X greater than W2 given X, then we will select W1. Here we minimize the risk. Why we minimize the risk? Because it's not only probabilities without taking some feature in consideration. Here we take one feature. Later we will see how to take more features, not only one feature. Yes. This condition, small one, conditional. We name it conditional. Feature one given specific class. This one, posterior, and the capital one, which is take the feature also. It's we name it prior. Okay, so doesn't matter the name. You should know the rule now. I will not check if it's P capital or P small. You just write the rule correctly, and that's the most important. This one, we can write it like this. Who focus and knows this come from where? From the formula, yes. Now, P W1 given X, if you look to the formula, so P W1, so J become 1, 1, 1, 1. So it's probability of X W1 multiplied by probability of W1 divided by probability of X. By the way, it's easy to memorize it. Probability of W given X, it's probability of X. Now it's the opposite, yes? X giving W, probability of W, probability of divided by probability of X. Okay, so this one instead of this one. So this one become what? Probability of X given W1 multiplied by probability of W1 divided by probability of X greater than probability of W2, sorry, W, I have to erase it. Okay, I have the eraser. I'm looking for this eraser. Okay, I'm writing here. Okay, probability of X giving W1 multiplied by probability of W2, sorry, W2 divided by probability of X, yes? Probability of X with probability of X. Yes, you remove this one with this one. Then you can move this one here, and you can move this one here. So it's become probability of, sorry, I have to erase these lines. Okay. Let me use a different color here. Different color. Is it different color? Yes. So this one with this one. This one come here to the down. It's up. When you send it to the other side, it's become down. This one up. You send it to the other side, it's become down. So it's the probability of X W1 divided by probability of X W2 greater than probability of W2 probability divided by probability of W1. Okay, so this decision rule and this decision rule same, yes, same, but it's another way. If you already have probability of X W1 or this one, actually you need to calculate it. So instead of go anywhere and calculate this one, you can use this one. Which one easier? This one or this one? First one or second one easier? If you said second one, you have to mention why. Okay, the easier is second one. You know why the easier is second one? Because for this one, you have to calculate this value and this value. And to calculate this value, you have to calculate probability of X. And the probability of X equals the summation of, you remember? This one here. Probability X giving WI multiply of probability of WI. Yes? Giving I equal 1 to number of classes. Maybe here 2, so 2. So you need to calculate more calculation here. Here you don't need to calculate the probability of X. So this, you have less steps for this way to calculate the decision. Okay, anyway, this way or this way, it's same. It's about probability of prior condition W1 given X. Same way here. If it's less than or greater than, sorry, probability of W2 given X, then we will select W1. You like this one, yes? Especially dx and the differential equation. Okay, we will not ask you about differential equation in this course. Okay, just to mention it here. We will not ask you to calculate differential. I like differential equation. Actually, I get, I don't remember exactly. I don't want to lie because I don't remember exactly. Is it 93 or 96 without attending any lecture? Yes. Actually, we can take a break now. It's let me just. I take the differential equation with one doctor